Hi, everyone. How are you guys doing? I'm Francesco, and I'm really excited to be here today with Tingmui and Subir from the Google Cloud Messaging team to introduce the new version of our platform. We launched GCM in 2012 to let you engage your users effectively and promptly notify them of important events. And all this while being thoughtful about battery life and network data traffic. And we made a long way since then. Since 2012, today, over 600,000 applications joined our platform. And every single second, we process over 1.1 million requests coming from you guys to deliver messages. And we help you reach out to a user base of over 1.5 billion devices. These numbers are pretty impressive. Let's look at them. 600,000 applications, 1.1 million QPS, 1.5 billion devices. You know what I'm going to. This year alone, we will be processing over 25 trillion messages from you guys. And as we receive this amount of growth, and we work really hard to keep the system scale, we are very focused and keep the system perform. Still today, to process a message that originates from one end of the world to the other end, we only take just about 50 milliseconds on average if the devices are online. And as we innovate in the space, we always keep an eye to make things simpler and more secure. Today, you will see a new, easy way to get started with GCM and a more powerful way to register with the service. But we always want to make things more useful so you guys can concentrate on building great apps. And we do this by adding features and APIs and tools, for example, like GCM topics, that lets you address your users horizontally based on their topic of interest. And a diagnostic tool so you can finally check what happens to your messages, all of them, as they move across our system. And finally, we want to have GCM everywhere. So you can reach out to all of your users, wherever they are, whenever it's important, on whichever screen they're looking at, with one simple and powerful service. As of now, GCM is able to deliver your messages to websites and to your users on iOS. And the best part of this is that all that you will be seeing today, everything we are launching today, it comes for you at the very same price. Everything is still for free. Thank you. And I'm very happy to say that along the way, we partnered with some developers. And today, the National Public Radio, Wattpad, and Samba.me, they're already using our new features cross-platform successfully and effectively. And you'll see later on what I have to say about integrating with GCM. So now let's take a step back. What is the basic feature of GCM? Well, we allow your server to send a message to your application on a given device when you need to. So for example, if you're writing a food application and we want to notify our hungry user that pizza is on its way, then you can use GCM. And the way to do this is really simple. We only need two things from you. First, we need a message, which in our case is pizza. And second, we need the address, which application instance on what device you want to target. And if you've been using GCM so far, you know that this address is the registration ID. Well, today, we're going to introduce a more powerful way to identify your applications. So let me go ahead and introduce the instance ID, which in 3 words is identity for robots, so they can meet and greet and chat just like we humans love to do. In a nutshell, the instance ID is composed by 2 parts. The identity, which lets you pinpoint which application instance you're referring to. For example, our food application on my Nexus 6. And this identifier is stable across the lifetime of our application. So until I go ahead and I install the food app from my Nexus 6. You can think of this as the username of your robot. And the second part is a security token, which on the same example, it could be the password of your robot. And you can rotate this if you feel it's been stolen or compromised by simply deleting it and generating a new one. And the security token is what you want to use to send messages with GCM. And to do this is really simple. When our user installs the food application on the device, we auto-generate an instance ID for you. All you need to do now is to call instanceid.getToken. You specify as a scope GCM, and we give you back the security token. Now, since we are in the scope and the context of GCM, we're going to call this security token the registration token. And as you did before, you send it to your server, and now you have the address. Now you can send pizza to the security token. But you can do much more. Now you can query information about your application instance and the device it's running on. So for example, you can get the application name, which in Android is the Android package name, the bundle ID on iOS, origin on Chrome, and you can verify that the application you're targeting to is actually your own. The version of the application instance you're referring to. So you might want to know what version our food user is using. And some information about the device. When is the last time you've seen it online? What type of connection was it, Wi-Fi or mobile? And attestation status. We are telling you if we believe the device your application instance is running on has been rooted or not. And you can make all sorts of decisions based on this information. You can read all about this and more and how to get started today on Instance ID as a standalone product or in conjunction with GCM on our newly designed developer website at developers.google.com/instance-id. And the best part of this is that it works the same way on Android, on Chrome, and on iOS. Since 2012, we've been reaching out to more and more devices. We first started with Android phones, tablets, Android wearables. Last year, we reached out to web applications on Chrome. And now, websites when your users visit them on Chrome and iOS. And GCM works the same way across all these platforms. So let's look at the websites with Chrome. All you need to do here is to implement the web push APIs. A simple call with your JavaScript on your web page to subscribe will give you back the registration token we just have seen before. So now, when your server sends a message to that registration token, Chrome will display it, just in this example, on your browser. And this works on Windows, Mac, Linux, and Android. On the Android device, the notification will show up with all the other notifications in the tray of the mobile operating system. And when the user clicks on it, we open your web page on the Chrome browser on your mobile device. For iOS, it's as easy as 3 steps. You first connect to a PNS server, and you get an APNS token. And then you do exactly what you did before. Instance ID.getToken, scope is GCM. Now you add an optional parameter, which is the APNS token, and we give you back the registration token. You send it to your server, and I can do 3 things. Query information about your application instance, information about the iOS device, and now you can send the pizza message to your hungry iOS user. And on iOS, the way it works is really simple. If the application is in background, we rely on the APNS server to deliver our messages. But as soon as our user clicks on our pizza application and it gets to the foreground, we connect directly to GCM so you can use the full power of our service. And now you can use all our APIs also on your iOS users. For example, upstream messaging. You can pack 1,000 devices into one message request with message multicasting. And these devices can be a mix and match between iOS, Android, and Chrome. And you can stream messages through an XMPP connection using our cloud connection server. You can read all this, and we have a dedicated section on iOS on our website at developers.google.com/cloud-messaging. And I would like now to invite Subir on stage to talk in depth about features and APIs on our platform. Thank you.
Thanks, Francesco. It's great to see GCM expanding cross-platform. So we know that with device group messaging, GCM can reach multiple devices with the same group. But let's step back a little. We heard when you send a message to a single registration token, GCM delivers that message to that specific device. But to send the message to another device, you have to send another message for that device's registration token. This works well when you want to target individual devices. But what if you want to reach multiple devices with the same request? What if you want to manage your notifications around a group of devices? With device group messaging, GCM lets you group together multiple devices and reach them at the same time. Just like a registration token is used like an address for a single device, for device group, we have notification key. Let's take a look at how it works. Like in the usual GCM flow, your devices register with GCM. They then send the registrations to your application server. After this, your application server can make a call to GCM to manage a device group. You can choose to create a new device group or update an existing one by adding or removing registrations from it. GCM will send you back a notification key for these requests. Here's a sample JSON request on how you can create a new device group. You need to send us some registration tokens. The notification key name is the name that you choose to identify this device group. And the operation specifies if you want to create a new device group or if you want to add or remove registrations from an existing one. In the response, GCM will send you back a notification key. Your server should store this notification key in order to target this device group in the future. How do you send a message to a device group? Really simple. All you need to do is set the to parameter of your request to this notification key. And the next time when you send a message to a device group, GCM will deliver it to all the devices in this group. You can have up to 20 devices in a single device group. A typical use case for device group messaging is to group together all the devices belonging to a single user. This way, your server can reach all the user's devices with a single request. It's pretty powerful. In addition to sending the message down to a device, your application can send the message upstream to a device group. And GCM will deliver it to all the other devices in this device group. You can use this to tell the other devices that a notification has been handled on one device, and then choose to dismiss it so that your user doesn't have to see the same notification on all of their devices. Enhances the experience. So with device group, we saw how you can group these devices and manage notifications with GCM. But what if you want to send the same update to a large number of devices? Users interested in common topics. You would still have to store their registration tokens and reach them individually, right? Well, not anymore. We're really happy to announce a brand new feature in GCM, topic messaging. With topic messaging, you can send the same update to a large number of devices. This API lets you create a topic of your choice, subscribe users to a topic, and then publish your update without having to track the individual subscribers. You can build a more personalized notification strategy around your users' interests. Let's take a look at how it works. You can subscribe your application to a topic. At any point, more devices can subscribe to the same topic. So earlier we saw the get token call to get a registration token. Once you have it, it's really simple to subscribe a device to a topic. It's one line of code. And that's it. Your users are now subscribed. Your server can now send updates to this topic. How do you do it? Simple again. You can set it in the to field of your request. It's the topic name that you chose while subscribing the user. And the next time your server sends an update to a topic, it reaches all the devices subscribed. Now let's think about an example. Let's go back to the food application that we discussed before. Let's say your users are interested in the awesome beer festivals here in San Francisco. They're nice. You can choose to subscribe them to the topic for beer festivals, and then send your important update to this topic. And GCM will then deliver it to all the devices subscribed to this topic. Now let's say one of your users decided to move away from San Francisco. Although we are sad to see them go, they probably are not interested in these festivals anymore. So you can choose to unsubscribe them. It's one line of code to unsubscribe a device from a topic subscription. And the next time you send another important beer update, it will reach the devices that are still subscribed to this topic. Topic messaging is available today, and we are launching with 1 million topic subscriptions. We will be adding more features to topic messaging, so stay tuned. We saw how with device groups and topic messaging, you can group your devices and manage notifications around them. Really happy to announce that both these features are available with GCM on Android, Chrome, and iOS. There is no need for you to keep track of individual device types when you publish your notifications. I hope you are excited about these features and would try them out. And now let me invite Tingmui on stage to talk about some of the GCM tools. Thank you.
Thank you, Subir. Hi, I'm Tingmui, Product Manager for Google Cloud Messaging. From Francesco and Subir, there are some really, really exciting features that we are launching here today. I hope you guys are all ready to start coding. Before that, let's see what we are also launching beyond APIs. So question first, who here are using GCM and ever wonder what happened to the statuses of the messages you're sending? Anyone? It has to be more than that. All right, so good news. Today, we are launching a tool that allows you to figure out what happened. It's a diagnostic tool on Google Play Developer Console so that you can start debugging messages sending to Android, Chrome, and iOS devices. And it's really simple. All you have to do is either enter a registration token, which has been introduced earlier as the application's instance identity, or a message ID, which is the identity that GCM returns to you when you send a message. Now, let's take a look at the demo. What you're looking at here is the Google Play Developer Console for an application that we have developed for this particular presentation. You could click on GCM Diagnostics on the left-hand side, where the cursor is right now, to start your debugging process. Let's see what happens if we enter a registration token. This very, very long string is the registration token for my device, for this particular application. When you enter a registration token to the tool, what you'll be able to find out is all the messages that have been sent recently to the device. you will be able to find out when the message that GCM received it by looking at the accepted time on the left-hand side, or as well as the message statuses of all these messages. So here we are seeing quite a few messages that have been collapsed, and then a message that has been acknowledged by the device. So being able to look at all the messages from a particular device is great. But what happens if you just want to figure out what happened to one particular message? Again, really simple. You could either enter the message ID into the input box, replacing the registration token, or if the message ID is already in the list, you could simply click on them. Let's take a closer look on one of these examples. Let's say the first one. Apparently, the device has acknowledged that it has received the message. Let's find out if we can find out anything interesting about this particular message. So when you input a message ID into the tool, what you'll be able to find out is the status, as well as when the status has changed for that particular message. In this particular case, let's see what we have. Apparently, this message was delivered to GCM when my device was not connected. But as soon as my device was connected, guess what? GCM sent the message, and my device acknowledged to GCM that, yes, the message has been received. So these are some pretty interesting insights, and now you will have that at your disposal to figure out what happened. Let's take a look at another example. There are quite a few of these messages with the status collapsed. So as a reminder, a collapsed message is a message that has been replaced by a newer message that is sharing the same collapse key. They are really useful, and one of the examples is, for example, when you want to send a sync message to your application so that the application can go to the server and fetch the latest information. Let's take a look at this third message that has been collapsed. Again, similar to the other message, we find out that this message was delivered when my device was disconnected, and then it got replaced by another message. So what I really like about this tool is that when it comes to collapsed message, instead of just knowing what happened to that particular message and when it happens, it's also able to tell you what happened after the message has been replaced. It will tell you what message replaced it, as well as what is the most current status of the message that shared the same collapse key. So if I scroll down a little bit, what we have here is the first row show you the message that we are looking at right now. No surprise there, it has been collapsed. It was indeed collapsed by the second message, which, again, was collapsed by the third message. But the good thing is, as you can see, the third message was actually delivered and acknowledged by my device. So we think this tool is going to be really, really useful for developers to debug. And we are making it available today for all of you so that you can start debugging messages sending to Android, iOS, and Chrome devices. You can send or look up to 30 message ID or one registration token at a time. The best of all this is that the data will be available to you within minutes after you send a message. Earlier, we have announced that we are launching GCM on iOS, and I assume that there are audiences here that have yet to use GCM. So in addition to launching a new diagnostic tool, we are also streamlining our onboarding process. The goal here is that developers can set up GCM within minutes so that you can proceed onto the fun part of coding as soon as possible. And for those who are keen on using GCM for iOS, this is also where you'll be able to upload your APNS certificates, both production and development, so that GCM can send a message on your behalf to iOS devices. So starting today, you can go to developers.google.com/cloud-messaging and start using GCM. We have described a lot of features today, and let's have a quick recap. Cross-platform, allowing developers to develop once and be able to send messages to users on Android, iOS, and Chrome. Topic messaging, an easy way for a developer to send personalized messages to your end user, improving the end user's notification experience, which in turn improve your re-engagement metrics. Diagnostic tools, making it super easy for developers to debug. Last, as we mentioned earlier, we are very happy that we are launching GCM and all the new features with a few developers. And we would love to share with you what they have to say about their experience with GCM. From NPR1, they are using topics on iOS and Android, and the integration has been really simple for them. Wattpad, leveraging the power of topics, they were able to send timely reminder to their users. Samba.me, with iOS, they were able to focus their engineering resource and build products that is best fit for their users. We hope you will be the next partners that will start using the features that we are launching today. Last but not least, you have heard about the new website that we are launching today as well. Developers.google.com/cloud-messaging with refreshed content and sample codes for both existing and new features. There is also a send feedback link at the upper right corner of the website. We want to be able to continue to develop features that best fit your product need. So please do leave us a feedback. Tell us what your notification experience could be made better. Thank you very much. I hope you are as excited as we are about all the features that we are launching today. And I'm going to invite Francesco and Subir back on stage and open up the floor for questions. Yes. Oh, the other person. Or
Sure.
So I think it was last year that you guys announced that GCM worked bidirectionally, that a device could get a message to a server through that way as well. Now, I haven't heard anything about it in the last year, but I think something was said just now that confirmed it exists. Can you confirm it?
So last year we actually took it out of beta and it was launched, and it's still there. It's called Cloud Connection Server. Francesco hinted on it in his talk. It's still there. You can send messages bidirectional.
Awesome, thanks.
So for those of us that already are using APN for our iOS devices, can you talk a little bit more about what that transition looks like? Do I just upload a couple million tokens to you guys and then switch our server over, and then you'll just take care of it as we upgrade our application and add eventually a GCM SDK, I'm assuming?
Yeah, it's really simple. So you plug in the SDK from us, our GCM iOS SDK. This is actually the instance ID iOS SDK. In that SDK, you will pass the APNS token. And then once you get the registration token from us, the library will do that for you. You just put it in your server, and now you can use it just like use it for Android. Right.
To clarify, I'm asking about the users that would not have yet updated. So will it have backwards compatibility for versions that on Apple that don't include the GCM SDK?
Well, what included your GCM SDK is your app, right? It's not the Apple device. So at some point, you will have two sets, like your old applications, and that you have to use the PNS in that case. And the new version of your application can be handled by GCM.
Got it.
Hi. Is there any plan to have access for the status of the messages via API or something like that? Or just by the console?
Yeah, so right now we're going to have it via the Google Play Developer Console, but that's definitely something that we are looking into it, and we'll keep you posted.
Okay, thank you.
Hi. I'm just wondering how you're mapping the GTM payload to APNS and how that's like working on your side. Are you gonna be thinking about like, there's no way you can like support image push, for example, on iOS via, I don't know, some widget or something like that.
Yeah, so we started really simple for now. We matched their payload type, so like 2 kilobytes, for example. As I mentioned before, your app in foreground will connect to GCM, but to make things simple for you right now, you don't have to think like, oh, it's foreground, it's background, what I'm gonna send. So we flattened to 2 kilobytes. We are hoping that they up their limits, but we are waiting for feedback for you guys. If we feel like it's a useful feature, then we can do tricks to actually build up more payload size and other features as well.
Cool. Just to be clear, we do support most of the common key values that Apple has, like badges and notifications. So take a look at our documentation.
Yes, the APIs are revamped to basically be a union of the systems, so you can take advantage of the full power of both. Right on.
Awesome. Thank you.
Are you doing any work on providing service level guarantees on the timing it takes to actually deliver these notifications? And also on throttling in terms of the open rates of the quality of the notifications that get sent?
Yes, it's a very interesting, complicated space. Especially after we send the message and the device receives it, it's very dependent on the network. There are Wi-Fi's or network carriers, and depends geographically by these carriers. We are doing a lot of work in the space to make sure that the system is extremely reliable and performant, right? So what we can do server side, what I mentioned before, it's when we control the environment, then we are pretty effective. But yes, we are reaching out to partners and carriers and to make sure that even the last mile is actually pretty good.
The second follow-up question was, are you doing anything on throttling misbehaving applications?
Can you repeat throttling?
Throttling of misbehaving applications that send too many notifications that don't have high open rates.
Yes, as you know, like we are always focused on make sure that battery life it's one of our main things, right? And spamming of messages on devices is one of our main focus to make sure that we don't DOS the device itself. So we do a lot of improvements in that area.
Hi, you mentioned that iOS clients, when they're in the background, will continue to get APNS. What does that mean in terms of latency? Do the messages get sent from GCM through APNS then to the clients?
Yeah, so when your app is in background, we can't really keep an open connection, right? So we have to rely on the APNS server and whatever APNS does. We do some improvements so that when your app connects and if you figure out that some messages weren't delivered, then we will do that for you. But as long as your app is in background, then it works as well as APNS works.
Since the devices acknowledge when they receive the notifications, they acknowledge it to the GCM server, yes? Are there any plans to create hooks to allow us know that it's been received?
Good question, and we actually have a feature for this. If you use CCS to get a message from the device, you can actually set that you want to know about the receipt of the message. We call it delivery receipts. And in the request, when you send the message, you can signal to us that you would like to hear back a receipt for this message, and you can get the receipts.
Okay, awesome. Thank you.
Cool. If there are no more questions, we have a sandbox section tomorrow, as along with a couple of Q&As, and we will be around to take offline questions as well. Thanks, guys.
Thank you.